When we look at a massive mountain range, it feels entirely permanent. The rock is so solid and heavy, it's easy to assume those peaks and valleys have simply always been there. But the truth is much more interesting. The surface of our planet isn't a finished solid shell. It's a highly active, constantly shifting canvas. Every single physical feature you see around you is the result of a permanent planetary tug-of-war between two invisible sculptors. One sculptor works deep underground, constantly trying to push the rock up. The other works entirely on the outside, using weather to sand the rock right back down. To see the patterns and how our oceans, valleys, and highest peaks were created, we have to look at how these two opposing forces interact. Let's start with the force working deep below our feet. The ground we stand on is actually made of tectonic plates, massive interlocking slabs of rock that fit together to cover the globe. This diagram of the Earth's interior shows three layers: a superheated core, a semi-melted mantle, and a thin outer crust. Look at the surface boundary. Our tectonic plates are fragments of this thin crust, resting directly on the hot mantle. Extreme heat rising from the core causes the semi-melted rock in the mantle to slowly boil and churn. It rises, cools, and sinks back down in big circles. As the mantle slowly rolls over, it drags those heavy surface plates right along with it. This is an incredibly slow process. These massive slabs of solid rock move at a microscopic pace, drifting only a few centimeters every year. That is roughly the same speed that your fingernails grow. But over millions of years, this relentless, invisible heat engine inside the planet provides the raw material and the immense upward force required to build the foundation of our physical world. When these drifting plates meet, things get dramatic. Where continental plates crash head-on, the rock has nowhere to go but up. It slowly buckles and folds high into the sky. This slow-motion collision is exactly how the Earth forms massive mountains, like the towering peaks of the Himalayas. In other places, plates do the exact opposite and pull away from each other. As a gap opens up, hot magma rises from the mantle to fill the empty space, eventually cooling to create brand-new ocean floors. Finally, some plates slide past each other sidewise. They don't create or destroy land here, but they often get stuck, build up immense pressure, and suddenly snap, sending shockwaves to the surface as earthquakes. The inside sculptor is incredibly powerful. By pushing and tearing the crust, it creates towering elevations and deep basins, but it leaves the rock rough, jagged, and unfinished. That is where the outside sculptor takes over. As soon as the land is pushed up, a natural process called erosion begins to wear those rough edges back down. This happens in a two-step technique. First, weathering occurs when extreme heat, freezing ice, and rain slowly crack the solid rock apart. Then, erosion acts as a transport system, sweeping those broken pieces away. The outside sculptor's most powerful tool is running water. Fast-moving rivers act like liquid chisels, slicing down through solid stone to carve out steep, V-shaped valleys over thousands of years. But water can't carry that heavy rock forever. When a river finally hits the ocean, it loses its energy and drops all that rich, ground-up sediment. This buildup creates flat, highly fertile, fan-shaped deltas at the water's edge. High up in the mountains, the sculptor uses ice. Massive frozen rivers called glaciers act like slow-moving bulldozers, violently scraping away the mountainside to leave wide, U-shaped valleys behind. In dry deserts, the wind acts like sandpaper, blowing grit to sculpt shifting dunes. And along the coast, ocean waves act like hammers, steadily pounding solid rock into sandy beaches. By sanding and smoothing the earth, the outside sculptor takes jagged, unlivable rocks and transforms them into the gentle valleys, wide plains, and fertile coastlines we rely on today. The geography of our world right now is simply the current score of a very long game. Every feature you see is the exact balance between the upward push from the mantle and the downward grind of wind and water. Human civilization has largely followed the path left by these two forces. We built our earliest societies and trade routes directly on the fertile river plains and calm coasts carved out by the sculptors. But living on an active canvas comes with real risks. Because we live right alongside the tools that shape the earth, we remain highly vulnerable to the side effects, like earthquakes, floods, and sudden landslides. Understanding the specific forces that build a mountain or carve a valley is exactly how we manage those natural disasters. It allows us to predict where the ground might be unstable, so we can protect our communities. Every mountain or coastline you see is a masterpiece in progress, a draft that the Earth's two sculptors are still working on today.